Hello, I am Ahnaf Mozib Samin from the University of Groningen in the Netherlands. And the title of our work is Arguments to Key Points Mapping with Prompt-Based Learning. So I'm going to first talk about our task and then the data set we used, and then the methods, results, and discussion accordingly. So with internet technology getting more accessible to mass people, we have lots of data, and it is becoming really difficult to categorize those data in an efficient manner. So people argue about many things on internet, including government policies, or different controversial issues like abortion, gun control, etc. And it is really important to how we can summarize those arguments in an efficient manner. So the key idea of this task is we can set some predefined key points, and we can map those key points to the arguments in order to classify the arguments in an efficient manner. So, so the task is argument to key point mapping, and it is about summarizing the arguments supporting each side of the debate by mapping them to a short list of talking points, and we call them as key points. So, for example, we have 7 arguments, and instead of these arguments, we can just use a short key point that is, that can be anything. So we have basically used a publicly available dataset, ArcKP dataset. And in this dataset, there are 24,000 argument and key point pairs. And out of them, around 20% are matching pairs. The argument and key point pairs are matched, and the rest of the 80% are non-match pairs. This makes the data set really imbalanced. And there are 28 topics. And for these 28 topics, there are for each topic, there are 8 key points. And these key points are set by these are predefined key points set by the expert annotators. So this is the data set. We have the topic name, and then the argument, and then the key point, and the stance is about, it can be either -1 or 1. So if it's -1, then the topic does not support the key point. And if it's 1, then the topic and the key point supports each other. And the label can be either 1 or 0. If it's 1, then the argument and the key point are a match. Otherwise, if it's 0, then it's a non-match. The argument and the key point are non-match. So we have done cross-domain, both cross-domain and in-domain experiments. And in our cross-domain data set, we have 19 topics in the train set, and 4 topics in the def set, and 5 in the test set. And we have a ratio of 71, 12, and 17% in each of these sets, respectively. So, in our in-domain data set, we have the same ratio in each of these split, and there are 28. You can find each of the topics in each of the splits. So there are very few work on argument to key point summarization, and the only work that used this data set, they used the fine-tuning method, directly fine-tuning method. And our contribution to this work is incorporating prompt engineering for these tasks to see if it's suitable to use it or not. So we have first created our baseline models, and then we have utilized 2 approaches, approach 1 and approach 2, which I'm going to tell. So for our baseline, we pass the argument and the key point pairs to a pre-trained language model. And after fine-tuning the language model, as an output, we get either a match or a non-match. So there is no prompt engineering involved in our baseline. And the only difference between our baseline and approach one is we use a prompt template for the approach one. So the argument and key point pairs are passed into a prompt template. And once we get a prompt, we pass it to the pre-trained language model and fine-tune it. And then we get the result as either match or non-match. And this is the framework of our approach, our second approach. So from our data set, we get the argument, and this argument is passed to a prompt template. And once we get a prompt, we pass it to the pre-trained language model. And from the pre-trained large language model, we get the intermediary text. And this intermediary text is then concatenated into with the argument and the key point pairs. And we have like 3 inputs now. The intermediary text from the output of our pre-trained language model, and the argument and the key point, and we pass these 3 into another classifier to map them either a match or a non-match. So here there are 2 classifiers. The first classifier is to get the intermediary text, and this adds additional information. And with this additional information, we pass all these 3 into our final classifier. So this is the result of our baseline, and basically we have trained 4 models, and we can, as we can see, the BART-based model performs better than the other ones, with 88.4% F1 score in the in-domain experiment, and about 72% F1 score in the cross-domain experiment. And for our approach one, we have used several prompt templates. So this is our first template. We have an argument and the key point, and the X1 and the X2 are the input slots, and the Z is the output slot. So we pass the argument to the X1 slot and the key point to the X2 slot, and the output slot can contain either match or non-match. So we have several other templates here. So these are like natural languages. For example, the third template is like, does the argument comprise the fact, then the keyword, key point, and then the either yes or no in the Z slot. And our fourth template has like a definition of what is a key point. So a key point is a summarization of the corresponding argument. In other words, an argument comprises a key point. Does the argument, and then we pass the argument, comprise the key point, then the key point, and it can be either yes or no in the output slot. So yeah, this is the result of our approach one. And for the pre-trained language model, we used T5 base model. And we can see from this graph the result for different templates. For the in-domain experiment, we can see the results are like same for every template. But for the cross-domain experiment, we can see there is some difference, like template 1 or template 2 getting 76.1% F1 score, whereas template 3 or template 4 getting only 72 or 77% F1 scores. So, and now talking about our approach 2, we have utilized 2 templates, and all of these templates are like manually curated templates, like we created those templates. And for our template 1, we have like 2 sub templates, one for the matching pairs and another one for the non-matching pairs. So we have to create sub templates because for the second classifier in our architecture, we need to have both the matching pairs and non-matching pairs, the examples from the matching and non-matching pairs. So yeah, so these are our two templates, the argument, this means, and then the key point. And the template 2 is like the correct key point for the argument is this key point. And for the non-matching pairs, the wrong key point for the argument, and then the argument is the key point. So for the cross-domain experiments, and using the template 1 of our approach 2, this is the result. So as our final classifier, we have used some machine learning algorithms like naive Bayes, SVM, or decision tree, and also some large language models, state-of-the-art language models like T5 and BART. So yeah, and the red colored bars are for those we get the intermediary text from the T5 small model, and for the blue colored bars we get the intermediary text from BART large model. So basically we also like investigated these two models to get the intermediary text, and as the final classifier we used these five models. And as expected, the machine learning algorithms are not up to the mark at all, and we get better results with T5 small or BART based. So, and this is the cross-domain results for using our template 2 and approach 2 also. And we can see the T5 small model, T5 model works better with our template 2, whereas the BART model works well with our template 1 for the cross-domain experiments. And in the in-domain experiments, we get like very good results with T5 and BART models for both in-domain and cross-domain experiments. So if we want to like look at all the results in one table, so our baseline without using any prompt template, we get 72% F1 score for the cross-domain experiment, and we get the best result out of approach 1, which is fine-tuning the T5 model and using prompt engineering, and we get 76% F1 score. And we expected our approach to might have good results, I mean better results with additional information, but we get like even a poor result than our baseline. So and this is the in-domain, this is the results for our in-domain experiments. And again, we get the best result using our approach 1, and our approach 2 is better than our baseline, however, not good enough compared to the approach 1. So we have we did some error analysis and why our approach 2 is not providing us better results. And our hypothesis is that like the approach 2 suffers from negation issue, because we have two sub-templates. One template has the correct argument for this key point is, so the correct and the wrong, these words or these negative connotations cannot be captured by the language model. So that might be a reason why our approach is not performing that well. So in summary, we have implemented prompt engineering for argument to summarization task with two approaches, and we have done both in-domain and cross-domain experiments with 7 different templates. And our main goal was to investigate whether prompt engineering is suitable for this task or not. And as you can see, like our using the approach 1, we got better result using the baseline compared to baseline. So yeah, prompt engineering is helpful for this task. And as future work, we can use automatic prompt generation methods. Like now we have used these templates, those are manually curated, but it's possible to use like machine learning or neural network to to get the templates from a model and then use it and then compare the results. And so we have fine-tuned these language models, but it would be nice to see like how does it perform with zero shot or few shot approaches instead of fine-tuning it. So yeah, that's it. And if you have any questions,